Hello and welcome to Chapter 5 in this series of videos where we look to create a 2D platform game in Unity. So for Chapter 5, we will just look at understanding 2D game physics inside Unity. So for the index for this video, first we'll have ground check and collisions. Second, we have the elements of the inspector within our player. And third, what to expect moving forward for future videos in this series. So now let's jump into Unity and I will discuss as further.
So let's briefly recap what we did in the last episode. So in the last episode, we were able to come up with a foundation for the player sprites and its animations. So let's just quickly show that as we build the game. So you see we are able to move left and right as well as jump. And the animations for these movements have been working very well. So we have the idle animation. You can see Mega Man blinking his eyes. You can see when we're moving left or right, the running animation. And when he jumps, he has a specific animation for when he's in the air. So now that we've established that, we first need to understand the physics of 2D platforming games. So the real basis for 2D platforming games mentioned from the first video is getting from point A to point B. So let's say we have a bunch of obstacles. We're just going to copy paste, and let's see what we can do, right? So you have, for example, you have this platform, you need to go to the other platform. It's very crucial to understand how 2D games work from a physics perspective. So obviously, you're going to need your collisions so that your player won't suddenly fall off the screen or like maybe fall off the stage. There needs to be collisions between the player and the environment, not just limited to the platforms, but later on when we create our own obstacles and enemies. So this is really the basic foundation for what a platformer is, right? So traversing from one to the another. Actually, I'm seeing that there's something that we can improve on, and that seems to be it might be on the fly, but let's create a physics material 2D. So we're going to apply that into the rigid body. Let's just make the friction 0. So the purpose of this, of your physics material, is so that, as demonstrated previously, you don't want the player to be sticking to walls like that, which will cause weird interactions when you, let's say, jump, like what I did earlier when you jump from one platform to another, but you hit the wall. So you don't want that to happen. So we're just going to apply that to the rigid body, and we're going to see what will happen now that we've hit. So we're just going to hit play, jump, and hit. Okay, that fixed the problem much better. So earlier you saw that we were like sticking to the wall. There's a bit of it, but it's not as jittery as it was previously. So that's one thing I forgot to point out in the previous video when putting the components of the player. So that's one thing that's very, very important in your rigid body. Speaking of the rigid body, you want the body type to be dynamic, as when you set it to kinematic or static, it might not behave properly as intended because rigid body is what handles the physics of the player. So it could be gravity or maybe how heavy they are or the drag that they have. So another important thing is taking note of freeze rotation. So earlier you saw how when the player jumps, they're still on the same orientation. So let's try and see if we freeze the rotation. So there, you can see that we rotate like a falling cube, and now there's no way for us to get back on. on the same orientation, it just looks really weird. So like there, when you see when I'm trying to jump, but since the rotation is unfrozen, I'm unable to, jump normally. So you always want to have freeze rotation on, unless of course you want to experiment and maybe try and make something out of it, then go ahead. But normally you want to trigger freeze rotations, or I mean, turn it on rather. So next is the Box Collider 2D. Now, the Box Collider is very important in making the hitbox for the sprite of your character or enemies, because you don't want it to be overly extended, right? So we try to modify that. So what if we extend it like that, right? So let's hit play and see what will happen. So there's a big amount of space, and you can see it's like we're hitting a wall, and that's because the Box Collider that we just it's causing problems with how the game should function. So we want to make sure that it should fit properly with the shape of your player or your enemies or the obstacles, so that it won't look awkward when you're making the game, or maybe when it's actually being played already, you will notice that the hitbox is way too big. But of course, it also can't be way too small, because let's say an enemy projectile hits you, but since the collider is so small, it should have registered as a hit, but instead just passes through and nothing happens. So that's most of what happens in the Box Collider 2D. So now let's move on to the player movement. So I previously talked about this during the last video, but that was mainly a very quick rundown of what things to do. So most of the things here in the player movement script are oriented towards the player movement and how the player reacts to certain environments. So the biggest part of the code is most likely comparing it to the ground. So in this example, we have if collision game object compared to ground, the player is not jumping and the player is instead is grounded. So let's demonstrate that. So in that line of code, it said that if the player's in collision with an object with the tag of ground, that means he isn't jumping and is grounded. So that's true. So because that's able to happen, that's the reason why we are able to jump in the first place. Then when we go one more tag where it says collision game object compared to ground, but this time on collision exit 2D, here Unity can explain it. It is called when this collider or rigid body has stopped touching another rigid body or collider. So since it's not touching anything with the tag ground in it, that means we are jumping, we are in the air, and we are not grounded. So that's what also enables us to call upon the other portion of the code where we are not able to double jump because we are jumping. So next is the flip, which is very basic. So if you click left or A or left arrow, that means you are facing to the left, -1. And clicking D or the right arrow is at 1. So that's why we want to flip, because you don't want him to be moonwalking where he's, like sprinting to the left, but he's facing the right direction. Unless, of course, you want to implement a mechanic where he's strafing or something, where he's slowly backing up, not fully turning his back. So other parts of the code are mostly tailored towards jumping, like the dynamic jump height. So like how high you want him to jump. And speaking of that, it's the jump power. So let's see if we decrease it, you can see that the jumping power is very, very weak. But if we increase it past 10, which was our default value, oh, there you go. You can see how powerful he is able to jump. So that's the reason why we have a serialized field for jump because that will be how strong you want your player to jump. Of course, that will be up to the developer on how high they really want the player to be jumping. Also, the speed, very important when you want to have maybe a fast-paced platformer, or maybe you want it to be very slow-paced. So, like for example, set it to one. You see how slow he can move, almost like he's moving in mud. So this goes hand in hand with the rigid body because it's interacting with the mass, its collision detection, or the amount of drag you do. But for the most part, you don't want to edit most of the values here unless you're aiming to be realistic towards a certain object that you are creating. So maybe when you're making a bullet, you want the speed to be very high. And maybe if you're animating maybe an anvil, like maybe something falling, you might want to edit the weight of the object, which also goes hand in hand with how fast. So now we have finished discussing and understanding the 2D game physics within our own prototype. So we've covered already how the sprites function, how the movement script functions and interacts with the platform and the player itself. And we've also understood how the animator component interacts with the animations that we have made and the settings that we need in order to make the game look more fluid. So lastly, we will just briefly have an index of what to expect for next video. So first will be the creation of a proper environment for our level. Second, applying sprites to the environment. And third is adding background music. So this is so that the environment of the game as we proceed with developing our prototype will bring more life. More life to the music, more life to the game so that players won't be bored when playing the game later on. So that will be all for this video and I will see you in the next video. Thank you.